Good morning, students. Let us see the basic construction of N-channel MOSFET or MOSFET. So MOSFET is abbreviated as metal oxide semiconductor field effect transistor. Now in this construction we'll see why it is called metal oxide semiconductor field effect transistor. Here we have a P substrate. This is a P substrate material. So here we are constructing an N-channel MOSFET. Here we are taking a P type of substrate. Substrate is, this is a silicon material, and substrate is the foundation on which any device is constructed. This is P substrate. To P substrate a contact is connected, that is nothing but substrate, and to the P substrate you have two N-type materials connected here, and these two N-type materials are connected to two contacts. One is drain and the other is source through metal contact, and another metal contact is connected to gate, where gate and drain are connected into the N-type material, where gate, drain and source are connected to the N-type material, where gate is not connected. So here this is a metal contact is there, even this is a metal contact, you have metal contact. Now here an insulating material like silicon oxide is coated here. This insulating material is called, that is nothing but silicon dioxide. So if you see, the name is metal, a metal contacts are there, oxide, an insulating material, oxide, silicon dioxide, and a semiconductor, because the P and N type materials are there, it is a semiconductor field effect transistor, because you have drain, source and gate, that's why it is called metal oxide semiconductor field effect transistor. Here the MOSFET are of two types. One is depletion and the another is enhancement. And the basic difference between the depletion type and enhancement type is, in depletion type you have a channel present between source and gate, whereas in the enhancement type this channel will be absent between source and gate. Let us see the working of N-channel depletion type MOSFET. Here we have a P substrate of, since it is an N-channel, you have a P substrate and a substrate terminal, drain, gate and source. Always the substrate and source will be internally connected. We'll connect substrate and source. Now we'll take the first case. VDS is equal to positive voltage, therefore you connect a positive voltage between drain and the source. We'll connect a positive voltage between drain and source. We'll connect a positive voltage between drain and source. You connect like this. This is the source terminal, we'll connect it positive. This is nothing but VDS, positive voltage. This is plus and this is minus, and we have to take VGS is equal to 0. So V and G and S are connected to ground. Now what happens with this connection? Well, let us see. As VDS, if you see, VDS is the, and here the in the channel electrons are the charge carriers. Here electrons are the charge carriers which get attracted towards the positive terminal of VDS, and electrons will move in this direction. Electrons will move in this direction. The current, conventional current, will be opposite to. Therefore, there is a current flowing like this, like this. Therefore, this current is called drain current. Now, as we increase the depletion layer, the current ID increases. Also, the depletion, as we increase the VDS voltage, also the current ID increases. Also, depletion layer also increases. Since this is a P-type material and N-type material, there will be a substrate diffusion. At some point of some point of VDS, this, at some point of VDS, the the depletion layer becomes more and the channel almost becomes narrow, and there will be no current flowing. Therefore, let us draw the characteristics of VDS versus ID. There, for VGS is equal to 0, here for VGS is equal to 0, Here, so initially the current will be increasing. After VDS equal to, when it reaches pinch of voltage, it will remains constant. The further the current will become constant, it will not further increase. Now let us see the second case where VGS is negative and VDS is positive. So same thing, VDS is positive, will connect to the positive terminal. VDS is connected to the positive terminal, source and gate are connected, and now gate is connected to the negative terminal. Between gate and source, negative voltage is there. So now let us understand here, negative voltage is connected. So let us take only this gate and metal contact and oxide material, channel and P substrate. So since the gate is connected to the negative voltage, electrons which are negatively charged ions will get repelled by the negative charge of this one, and holes which are positively charged get attracted towards the negative terminal of the gate. Therefore, as a result, the electrons are moving away from the gate. Therefore, the current ID decreases or reduces. Therefore, for VGS is equal to 1, the ID, whatever the current ID which become constant, will be at lower level than VGS equal to 0. Therefore, we have plotted the graph like this. Now let us take VGS is equal to positive and VDS is equal to positive, and this is an important case where when we are seeing the working of JFET, we don't take VGS is equal to positive and VDS is equal to both positive, don't take. Only in case of Mosfet only will construct this one. This is a very important point where VGS is equal to positive and VDS is equal to positive. What happens? Let us see if VDS and VGS are positive. Suppose the gate is connected to the positive terminal, the here holes which are here P type will have majority charge carriers as holes, and electrons are the minority charge carriers. Here these electrons will get attracted towards the positive terminal of the gate, but it cannot further pass to the gate because it is having a insulating material. Therefore they get accumulated here. Therefore more and more electrons get collected here. That's why ID current increases. Therefore we'll take here the current positive VGS is more than this one. Now let us see this characteristics of VDS versus ID is called drain characteristics. Now let us see how to plot a transfer characteristics of N-channel MOSFET. Now let us take here the drain characteristics. Already we have considered different cases. VGS is equal to 0. For VGS is equal to -1, ID decreases, therefore we have taken down. And for VGS is equal to positive, electrons get accumulated, therefore the current ID current increases. Let us take VP pinch off voltage as -3 volts. So let us see how to draw the transfer characteristics from the drain characteristic. This is the same method for the JFET and also for the MOSFET. Here let us draw the characteristics. Now let us take, this is current ID, this is ID versus VDS. Now whereas transfer characteristics VGS versus ID. Now let us take this VGS is equal to 0 and this is VGS equal to 1 and VGS equal to -1, -2 and -3 and current ID. Now for VGS equal to positive, so now just take the positive voltage here VP and extend this here where it cuts the positive line VGS equal to 1 and extend this positive line and this line. So take this point here, take this point here. Similarly for VGS equal to 0, extend this line and also this line where it meets this line, that is nothing but another point. For VGS equal to -1 also extend this line and also this, and for VGS equal to -2 also extend these two. Connect all these points, you get the transfer characteristics which is exponentially increasing. This is the transfer characteristics of N-channel MOSFET. In the next class, we'll discuss the depletion type with enhancement of N channel MOSFET. Thank you.